This is SpaceTime, Series 23, Episode 45. Coming up on SpaceTime. Using colliding neutron stars to detect exotic Quark-Gluon Plasma. Jovian cloud-like bands discovered on the nearest brown dwarf to Earth. And Ariane 6 appears to be still on track for a maiden flight this year. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
New computer modelling has suggested that an exotic substance known as Quark-Gluon Plasma, which is generated by emerging neutron stars, could be detected through gravitational waves. Quark-Gluon Plasma is the substance which filled the entire universe during the first few milliseconds after the Big Bang 13.82 billion years ago, from roughly 10 to the minus 10 to 10 to the minus 6 seconds after creation and before the formation of matter as we know it today. It's composed of quarks, which are a type of elementary particle that make up protons and neutrons. They can usually be found in the nucleus of atoms. And gluons, which are another elementary particle which acts as a gauge boson for the strong nuclear force between quarks, and which also binds the atomic nucleus together. Quark-Gluon Plasma has been recreated in particle accelerator collisions on Earth, and it's previously been hypothesized as existing at the centers of neutron stars. Neutron stars are the densest objects in the universe other than black holes. They're created when massive stars far bigger than the Sun explode as core collapse supernovae. These events are so powerful, they crush the electrons and protons that make up atoms into a sort of neutronian fluid. The end result is an object somewhere around 1.5 times the mass of our 1.4 million kilometre wide Sun, crushed down to an almost perfect sphere just 20 kilometres across. When two neutron stars collide and merge, they usually collapse to form a stellar mass black hole. But alternatively, if their masses are just right, they could form a hypermassive neutron star, in which the matter in the core of the new object becomes so incredibly hot and dense it dissolves any remaining neutrons and protons into their component quarks and gluons, thus producing a Quark-Gluon Plasma. Back in 2017, it was discovered for the first time that merging neutron stars send out gravitational wave signals which can be detected on Earth. This signal not only provides information on the nature of gravity, but also on the behavior of matter under extreme conditions. However, when these gravitational waves were first discovered in 2017, they weren't recorded beyond the merging point. And that's where this new study, reported in the journal Physical Review Letters, comes in. The study's authors simulated merging neutron stars and the product of that merger to explore the sorts of conditions under which a transition from hadrons, such as protons and neutrons, into a Quark-Gluon Plasma would take place, and how that would affect the corresponding gravitational wave. The simulation produced a Quark-Gluon Plasma, and it left a clear and characteristic gravitational wave signature. The study's lead author, Luciano Rizzola from Goethe University, claims that compared to previous simulations, this new gravitational wave signature was clear and easy to detect. So, if the same signature were to occur in a real gravitational wave received from future neutron star mergers, it would be clear evidence for the creation of Quark-Gluon Plasma in the present universe. This is SpaceTime. Still to come, Jovian-like cloud bands discovered on our nearest brown dwarf neighbour. And despite the global COVID-19 coronavirus pandemic, Ariane 6 is still on track for its maiden flight this year. All that and much more still to come on SpaceTime. Astronomers have discovered that the nearest brown dwarf to Earth has cloud bands similar to those seen around Jupiter. Brown dwarfs are failed stars that don't have enough mass to trigger the core nuclear fusion process which makes regular stars like our Sun shine. Instead, they fill the gap between the largest planets, which are around 13 times the mass of Jupiter, and the smaller stars, known as spectral type M red dwarfs, which are around 75 to 80 times the mass of Jupiter, or if you prefer, 0.08 solar masses. Astronomers studying the brown dwarf Lumen 16A observed cloud bands similar to those seen on Jupiter and Saturn. It's the first time scientists have used a technique called polarimetry to determine the properties of atmospheric clouds outside our solar system. Lumen 16A is part of a binary system containing a second brown dwarf, Lumen 16B. At a distance of 6.5 light-years, it's the third nearest system to the Sun after Alpha Centauri and Barnard's star. Each of the two brown dwarfs in the system has about 30 times the mass of Jupiter. Despite the fact that Lumen 16A and 16B both have similar masses, similar surface temperatures of about 1,000 degrees Celsius, and presumably both formed at the same time, they have remarkably different weather systems. Lumen 16B shows no signs of any stationary cloud bands, instead exhibiting evidence of more irregular patchy clouds. And this means Lumen 16B has very noticeable brightness variations as a result of its cloudy features. Researchers used an instrument on the Very Large Telescope in Chile to study polarized light from the Lumen 16 system. Polarization is a property of light that represents the direction of the light wave oscillation. It's the same principle employed by polarized sunglasses to block out one direction of polarization, reducing glare and improving contrast. But instead of trying to block out the glare, in this study the astronomers were measuring it. You see, when light's reflected off particles such as cloud droplets, it can favour a certain angle of polarization. And by measuring the preferred polarization of light from the distant system, the authors could determine the presence of clouds, even though they couldn't directly resolve either brown dwarf's cloud structure. To work out exactly what the light encountered on its way through the brown dwarf's atmosphere, they compared their observations with a range of models of brown dwarf atmospheres, such as ones with solid cloud decks, ones with striped cloud bands, and even brown dwarfs that are oblate due to their fast rotation. And the authors found that only models of brown dwarf atmospheres with cloud bands matched the observations they were getting from Lumen 16A. This is SpaceTime. Still to come, Ariane 6 on track for its maiden flight this year. And later in the science report, warnings that cell phones could be acting as Trojan horses for coronavirus. All that and more still to come on SpaceTime. Okay, let's take a break from our show for a word from our sponsor, Expressvpn, rated #1 by TechRadar. You may be wondering why you need a virtual private network. Well, it's in the name. It's all about privacy. Do you really want big brother tech companies, hackers, governments, and who knows who else snooping in on your online activities? Now, you might not have anything to hide, but it's still really creepy, and it could be dangerous for you and those you care about. Also, how often do you run across a website and you want to get information from it, but you find out that they're geo-blocked? It's all very frustrating, and it's becoming an increasing problem. And that's where Expressvpn can help you. Expressvpn's a simple and efficient way to protect your online privacy. It's internet without borders from the world's leading VPN provider. So, protect your online privacy today and find out how you can get 3 months free at tryexpressvpn.com/space. That's tryexpressvpn.com/space for 3 months free with a 1-year package. Visit tryexpressvpn.com/space to learn more. And of course, you'll find the link details in the show notes and on our website. That's tryexpressvpn.com/space. And now, it's back to our show.
You're listening to SpaceTime with Stuart Gary.
Well, despite all the setbacks being caused by the global COVID-19 coronavirus pandemic, the maiden flight of the European Space Agency's new Ariane 6 rocket is still slated to take place before the end of this year, launching 30 small OneWeb broadband satellites into orbit. The new Ariane 6 heavy lift launcher, which will replace the existing Ariane 5 rocket, has taken a workforce of over 600 companies from 13 European nations, including 350 small and medium-sized enterprises, to fine-tune the design and start spacecraft production. At the same time, the European Space Agency has been completing final touches to its new Ariane 6 vehicle assembly building and launch complex at the Kourou spaceport in French Guiana. The new Ariane 6 core stage will be powered by an upgraded Vulcan 2.1 version of the existing Ariane 5 Vulcan 2 main engine, still burning liquid hydrogen and liquid oxygen. Depending on payload requirements, attached to the core stage will be either 2 or 4 strap-on P120C solid rocket boosters. The same boosters are used as the core stage for the new Vega C launch vehicle. It'll also undergo its maiden flight this year. The new Vulcan 2.1 engine will help propel Ariane 6 during the first 10 minutes of flight, up to an altitude of around 200 kilometres, delivering 135 tonnes of thrust. Already, 2 complete Ariane 6 launch vehicles, one for ground test at Kourou, and the second, an Ariane 6-2 for the maiden flight, have now been completed, and work is continuing on the first series production batch of 14 Ariane 6 launches, slated to fly between 2021 and 2023. The new launch vehicle will have a new upper stage, using the new Vinci reignitable liquid hydrogen and liquid oxygen engine, which will also ensure the upper stage will deorbit following payload deployment. The idea being to reduce the amount of space junk up there. Meanwhile, a new upper stage using composite materials known as Phobius is also currently under development. This report from ESA TV.
In the forests of Lamphaushausen near Stuttgart lies the German Aerospace Agency's Institute of Space Propulsion. Over the last 40 years, nearly all the liquid propulsion engines of every version of the Ariane launch vehicle have been tested here, and ESA's new Ariane 6 is no exception. With its maiden flight in sight, many of its components are being checked here. To accommodate this new vehicle, several of the test facilities have been modified.
So for the moment we have the P41, which is a high-altitude test facility where we have made already the development and qualification testing of the Vinci engine. And we have the P5, which is testing currently the main stage engine, the Vulcan 2.1 for the Ariane 6. And we are now in the process of accepting the new test facility for the upper stage, which is called the P52.
This P5.2 facility is new and has been specially built to test Ariane 6's upper stage. It looks like a launch pad, complete with different floors in a tower, similar to the ones at Europe's spaceport in French Guiana. Operations inside this facility are monitored from a central control room. After final preparations, a countdown marks the start of the test, just like an actual rocket launch. The Ariane 6 upper stage incorporates the Vinci reignitable rocket engine. This reignition is a key feature, adding versatility to Ariane 6 missions. While this engine has already been hot fire tested, it's essential to also understand the overall behavior of the whole upper stage before Ariane 6's maiden flight.
In the development of a launch system, you want to test the stages in the closest condition to the flight one. So we want to have a real stage test and not just a giant test, which is performed in another test bench close by here.
At the Ariane 6 upper stage test stand, all aspects of the flight are simulated, such as the preparation of the stage and also the flight itself. It's important to know how the upper stage behaves when the Vinci engine is running. The upcoming launch of Ariane 6 generates a lot of activity here in Lamphaushausen, but also in factories and research centres all over Europe, and of course in Kourou, where a massive launch pad is being built. For the development of Ariane 6, the approach is new. Design and manufacturing are done almost in parallel. An important task for ESA and European industry.
The difficulty of Ariane 6, the challenge of Ariane 6 is also given by the schedule, and we know that we had a little bit more than 5 years to build the old launch system and to qualify the old launch system, and this is a real interesting kind of challenge that we have, because we have to coordinate, synchronize many developments at the same time.
Despite this tight schedule, the many parallel builds and developments, ESA and industry accepted the challenge to develop this launch system in only 5 years. From Kourou to Lamphaushausen, the development of Ariane 6 continues at full speed in order to offer a competitive launch vehicle for the commercial market, while at the same time securing Europe's independent access to space.
And that report from ESA TV featured Anja Frank, Head of Test Facilities Department with the German Space Agency DLR, and the European Space Agency's Ariane 6 Launch Systems Architect Manager Pier Domenico Resta. Meanwhile, ESA's Director of Space Transportation Daniel Neuenschwender says Ariane 6's development is continuing, with future advances to be installed as they become ready. This includes the new POTIS upper stage, as well as similar improvements for the Vega sea launch system.
The development is going full speed ahead, which does not mean that you do not face some challenges, of course. But I'm very happy to report that the Ariane 6 development is going ahead, full speed. And in addition to that, and I think that's a key aspect, is that industry just now started production of 14 launchers, Ariane 6. The reignition of the upper stage allows you to deploy constellations in different planes. It allows you to increase the versatility of your launcher for different missions, also for escape missions for exploration. Today we are already thinking about the evolutions of Ariane 6 and Vega C. On both launchers, there will be a dedicated focus on the upper stages of both launchers in terms of engines, in terms of structure to be adapted, because at the end of the day, the last stage or the upper stage is the one which will deliver the satellite or the satellites, plural, in orbit. And this is where a number of flexible aspects can be brought in, so we are keen to work on this.
That's Daniel Neuenschwender, ESA's Director of Space Transportation. Meanwhile, a workforce of more than 600 people has been finishing up construction of the new Ariane 6 launch complex in Kourou. The massive launch pad, some 28.5 metres deep and 200 metres wide, required some 167,500 cubic metres of concrete. That's enough to fill 67 Olympic-sized swimming pools. One of the key components, the 700-ton launch table that will support the Ariane 6 at launch, has now also been assembled and positioned on the launch pad. This massive structure is so big it arrived in several separate parts by ship and was then welded together and fitted with some of its equipment at a preparation site about 250 metres from the launch pad. Moving this massive structure into its permanent position at the centre of the launch pad was a complex procedure. First, a temporary railway had to be built. Hydraulic jacks were then installed and a mechanical guidance system used to roll the giant 4-metre high, 20-metre long and 18-metre wide table into position. Once it was positioned exactly over the centre of the pad, it was then lowered with millimetre precision into its final position, where its mechanical, hydraulic and electrical equipment were installed. Also now in place is the 8,200-ton mobile gantry, which will store and protect Ariane 6 until it's retracted about 5 hours before each launch. This is SpaceTime. Still to come, the science report, including warnings that cell phones could be acting as Trojan horses for coronavirus, and logging found to have had a profound effect on this year's catastrophic Australian bushfires. All that and more still to come on SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with a science report. Scientists have conducted a review of 7 studies which have looked at using the drug hydroxychloroquine, that's the one touted by US President Donald Trump, finding it really is worthy of further study as a treatment for COVID-19. A report in the Journal of Medical Virology found the drug may help ease fever, and one suggested it may help people's coughs clear up as well. Overall, they found the drug also appeared to slow the progression of lung disease, but there was no evidence that it can actually cure COVID-19, clear up all the symptoms in a significant way, or save lives. A new study warns that cell phones could be acting as Trojan horses for coronavirus, and it's urged the billions of users of mobile phones worldwide to decontaminate their devices daily. The research by scientists at Bond University reviewed 56 independent studies from 24 countries, finding that phones actually host a staggering cocktail of live viruses and bacteria. The systematic review, which actually predates the current COVID-19 pandemic, found golden staph and E. coli microbes were among the most common bugs on the phones. The authors, reporting in the Journal of Travel Medicine and Infectious Disease, say cell phones and touchscreens are sort of like 5-star hotels for bugs, providing safe temperature-controlled environments and a free buffet for microbes to thrive on. They're urging anyone with a cell phone to decontaminate their device daily. A new study has shown that logging of native forests increases the risk and severity of wildfires and very likely had a profound effect on the recent catastrophic Australian bushfires. The findings, reported in the journal Nature, come in the wake of Australia's worst forest fires in recorded history. The devastating bushfires killed at least 34 people, destroyed more than 6,000 buildings, including 2,779 homes, burnt out some 186,000 square kilometres, and killed more than 1.5 billion animals, including many highly endangered species. Paleontologists have identified the first near-complete skeleton of a Gondwana therian, a badger-like mammal which lived on the ancient supercontinent of Gondwana. The 70-million-year-old fossils were discovered in Madagascar in 1999. It's been named Aldotherium hui, from the Malagasy word meaning crazy and the Greek word for beast. That's because it features a distinctively unmammalian large hole at the top of its snout, forelimbs which are aligned with the spine typical of a mammal, while its back legs are more spayed out, like those of a reptile. The crazy beast had previously only been described from a few pieces of jaws, teeth and skull. The new, more complete discovery, reported in the journal Nature, provides a far more complete picture, and appears to represent a young animal around 3.1 kilograms, making it among the largest known mammals of the era, which was dominated by the dinosaurs. Researchers say their larger size is likely to be due to evolving in isolation on the island of Madagascar. Iran has unveiled a new coronavirus detector. The problem is, it looks almost identical to the fake bomb detector Tehran was flogging a few years ago. Iran's Islamic Revolutionary Guard, Major General Hussein Salam, is promoting the new device, claiming it's an amazing scientific high-tech marvel, capable of detecting coronavirus in just a few seconds from a distance of 100 meters. He says that means there's no need for blood tests or putting health workers in any potential danger of infection. But the thing is, this same device has previously been flogged by the Iranian government's Islamic Revolutionary Guard as a bomb detector, as a device able to sniff out fuel smugglers, detect people with AIDS, and even find lost golf balls. Back in the days when this device was being pushed as a bomb detector, Iran managed to scam millions of dollars from gullible governments across the Middle East and as far away as Thailand. In 2013, the Egyptian government pushed a similar device, claiming it was a tool for detecting hepatitis. The gadget's now being called the ADE 651, and I'm sure as a special offer if you buy it today, you'll get a set of steak knives, plus a block of apartments and Tasmania. And that's the show for now. SpaceTime is broadcast on Science Zone Radio by the National Science Foundation in Washington, D.C., and through both iHeartRadio and on TuneIn Radio. Or you can subscribe and download SpaceTime as a free podcast through Apple, Stitcher, Bytes.com, Pocket Casts, SoundCloud, Spotify, YouTube, Audio Boom, Podbeam, Android, Castbox, from spacetimewithstuartgary.com, or from your favorite download podcast provider. You can help support the show and the work we do by visiting the SpaceTime online shop and grabbing yourself a few goodies, or by becoming a SpaceTime patron, which gives you access to commercial-free double-episode versions of the show, as well as bonus audio content and other rewards. Just go to our Patreon page through spacetimewithstuartgary.com for all the details. If you want more SpaceTime, check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, at SpaceTime with Stuart Gary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to www.facebook.com/spacetime with Stuart Gary. SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.